This video is going to be a walkthrough of doing the 2016 District 1 problem number 7, Tomas. So in this problem, we've got something that looks almost like something called the Fibonacci sequence from math, where the pattern here is we've got 1, 1, 3, 5, 9, 17, and we add up the first 3 to get 3, add up the next 3 to get 5, add up the next 3 to get 9, and so on. 3 plus 5 plus 9 is 17, and so on. Now, at first glance, this might appear to be, if you're in any computer science class, this is the type of thing you would use recursion for in a lot of classes, just to use recursion. But we're actually going to be not wanting to use recursion because we're going up to possibly 50 numbers, and we'll get a stack overflow if we try to use recursion here. It's going to just try to have it's going to have too many recursive calls. So instead, since we know up front exactly how many values we're going to go up to, we're going to use an array for this. Okay, so we have an array of integers, and we're basically going to fill in that array up front using this pattern. This 1 plus 1 plus 3, or really it's if we're looking for this number, we add up the 3 previous elements. So we'll use that, we'll fill in the array, and then once we have the array filled in, then there'd be one little trick to it, because this input is lacking, and I'll explain that in a little bit, and we'll get it working for any number. So let's go ahead and get started. Like I said, the first thing I'm actually going to do, I've got my scanner and stuff made because, well, that's the same as every other problem, but I'm going to go ahead and make that integer array up front. So I'm just going to say int array, let's call it nums equals a new integer array, and it's going to have 51 things in it. Now you're saying, why 51? Well, since we're going from 1 to 50, it'll make it easier if we just go ahead and have the indices align. So when n is 1, that'll be index 1. When n is 50, that'll be index 50. But we still need index 0. So that's kind of what's happening there. So that's why we have to go up to 51. So we got 51 things. And we can go ahead and say, well, nums at 1 is 1. Nums at 2 is 1. And nums at 3 is 1. Now, don't get me wrong, we could keep typing and say nums at 4 is 3 and nums at 5 is 4 and whatever, but we don't want to do that. Instead, we're going to use a for loop. We're going to say for int I equals 4. So we're going to start at index 4, and as long as I is less than or equal to 50, we're going to increment I. And then we're going to say that nums at index I is equal to the sum of the indices, the 3 previous indices. So we're going to say nums at I minus 1 plus nums at I minus 2 plus nums at I minus 3. So this little 2 bits of code is going to fill in this array of 50 elements with all of the appropriate numbers. Sort of. There's something wrong with this. You may already know what it is. If it is, then if you do, then just stick with me until I get to that point, and we'll see what it looks like and how to tell that it's wrong. It's not a compiler or like that. It's actually has to do with the data type we're using here. But let's go ahead and get back to our input. We're going to read in some numbers, and we're going to output the value in the array. So I'm just going to say while n.hasNext. Int n equals in dot next int, and then we're just going to say out dot println nums at index n. All right. Now, when I run this, I want you to keep in mind the data we have. We only have 5 numbers: 1, 3, 5, 7, 9. So when we run this, we have 1, 3, 5, 7, 9. Now remember, we actually have the judges data, so we're going to see a lot more than that. And you're going to see some weird numbers, but notice that 1, 3, 5, 7, and 9, they all give the right values. Right, so we get 1, 1, 5, 17, and 57. 1, 1, 5, 17, 57. Okay, so at contest, you're very likely to say, oh, okay, I've got it working, and move on and try to submit. But you'll notice that when we get down here, suddenly we jump to a negative. And this is an indicator of an overflow. What that means is that whatever value is being input right here, it's larger than an integer can hold. Now remember, integers can only hold 32 bits. Well, really it's 31 bits. So the largest value for an integer is 2 to the 31st minus 1, which is a pretty big number. But what happens is when you get past that number, instead of giving an error or something, Java just rolls back around and you start getting negatives. So if you're doing a problem like this, especially if they're big numbers and you submit it and it doesn't work, it works on yours and you submit it doesn't work, that's usually an indicator that it's overflowing. It's going past the end of an integer. And the easy way to fix that, at least the first fix that you try, is we use a long. Okay. Now a long is a 64-bit data type, so it can hold 2 to the 63rd minus 1, which is a very large number. If I save this and I run the code, we now see that we get these values, and if we compare that with the tomas.out, we can see that those are the correct values. Now, with that being said, sometimes it's not clear, and it's really up to you if you want to take the chance of losing 5 points and submitting with long. It may be larger than a long even. In that case, you're actually going to want to use another data type. So I'm going to use, we don't have to use that data type here, but I'm going to use this opportunity to introduce it just so you see it. So that data type is called a big integer. So I'm going to say import java.math.big integer. And you'll notice, I'm going to back up here, there's also a big decimal. So if you need very large decimal values, you can do that as well. So we have big integer. Okay. Now, you don't have to memorize how this works. Remember, we have the ability of using our API. So on our computer, we have our API, and we can just come in here and type in big integer, and we can kind of get an idea of how this class works. We can see what methods it has and things like that. So we have constructors. We can see it'll take in a string. That's usually how you're going to want to create a big integer. And then it has some methods add. That's usually what you'll use. Add, there's the add method. I believe there's a multiply method for multiplying two big integers. There's probably a divide method someplace. Yep, divide. And I'm sure there's a subtract method. Yep, subtract. So if you're going to do operations between two big integers, you have to use these methods. And then it has some constant values like 1 and 10 and 0 and 2, so we use some of these things. All right, so let's go ahead. So this right now works, but like I said, I'm going to go ahead and go from long to a big integer just to demonstrate how to do that. And so instead of long, I'm going to say big integer. Now, 1 is an integer. If I want 1 to be a long, I would have to put a capital L after it, and then it would understand as a log. If I want 1 as a big integer, I have to say big integer, and I can either say 1 like this, or I can say big integer dot 1. Either way. So I'm just going to use big integer dot 1, and then for this last one, I'll do the other way. Big integer 1, just so you can see. They actually do the exact same thing. Actually, I have to say new. To say new big integer 1. So notice big integer dot 1 is a big integer reference value. I'm sorry, it's a big integer constant, and so it'll just assign that value here. If I'm going to actually create a big integer, I have to say new. So you could actually, you can say 10 there or something. It would make a big integer called with the value of 10. Okay, so now we want to add two big integers. I'm going to start with the rightmost one, although it doesn't really matter. And so remember, nums of I minus 1 and I minus 2, I minus 3, these are all big integers. So if I want to add them together, I have to use the add method. So I'm going to say nums I minus 2 dot add nums I minus 3. And then likewise, nums I minus 1 dot add, and then this whole thing right here. And so it's going to work its way out. It's going to add these two together, which gives a big integer, and then it's going to add that big integer to this one, and then it's going to assign to our big integer over here. And that should be the only changes necessary to make this thing work with a big integer, which means it would work for extremely large values. So I'm going to go ahead and save and run, and I should be getting the exact same output. I'm not expecting a different output. There we go. Notice that in this case, the long and the big integer did the exact same thing, but I have seen problems where even longs are too small to hold the final value. So you want to be familiar with big integer, and then likewise, like I say, with big decimal. When that problem arises and you need a big decimal, you can always just go right here and you can read about math.bigdecimal, and it lets you go create large numbers and also numbers with a lot of decimal places. So useful classes when you need them. So all right, so that should be it. Thank you.